In 1948, Shannon was an American mathematician and electronic engineer, and Weaver was an American scientist. Both of them joined together to write an article in Bell System Technical Journal called A Mathematical Theory of Communication, and also known as the Shannon-Weaver Model of Communication. This model can be used to represent communication in many different forms, including conversations. Here it is slightly different, as the element of noise has been added. This will become more important as we discover more about. So let's take an example. A sender, let's call him Michael, needs to tell Linda about a meeting. The channel in this case is the air, as he is in the same room as her and he is speaking using his vocal cords. So what is the encoder? In this case he is speaking in English, which luckily Linda is able to decode. Linda lets Michael know she will be there by nodding her head. We could draw another model of communication for this, as it has a sender, encoded, channel and decoded and received. But for now we'll call it feedback. So now let's add in some interference or noise. The same sender, Michael, still needs to tell Linda about a meeting. However, this time, in the office there are some noise. General office chatter, computers humming, printers printing, etc. However, this time, with this interference, Linda didn't quite catch all of the message. And her feedback this time is, can you please repeat what you said? Which means, and as long as Michael didn't get interference on that channel, he would be able to repeat his message. So using this model again, we can now apply it to data communications. A sender, this time, is Michael. He's using a PC to send an instant message. The receiver is still Linda, and she's using her PC. So the first level of coding is English, typing into the keyboard. This is then encoded into a language the PC can understand, and then encoded onto the channel, in this case ones and zeros. The channel in this case will be copper cable, and the message ones and zeros, which appear as voltages on the line. We can adapt this to any mode of communication, and it is data communication that manages the encoding and decoding. In this diagram, you can easily see the transmitter and receiver, but the channel and encoding are a little more difficult. In a mobile network, the signal is transmitted to a mast, which in turn is transmitted into the network to probably a switch somewhere, then transmitted to the destination mast, which is then transmitted onto the called. Each leg and each phase of the establishing the link and sending the message is a Shannon-Weaver model, which we will learn more about as we go through this course.